we want to build a DC generator where we don't want the current direction to change. We want it to remain the same throughout. Let's say in this direction. How do we do that? Well, to build that, first let's get rid of these rings. All right, now to make sure that the current direction remains the same, what we will need is that these brushes to continuously keep changing contacts between these wires for every half a rotation. Let's see why. So if I want the current to flow this way, right now in this position, I can connect this brush to this wire, so the pink side, so that the current flows like this and comes out. But as the coil rotates, notice once it comes to this position, we have seen that the current starts flipping, current reverses. And so now, to maintain the current in the same direction, we would now require this brush to come in contact with this wire. That is the blue side, right? And then again, once we come to this position, again it flips, the current flips, and again we would want now this brush to come in contact with this side. And so as a result, can you see that for every half a rotation, we would want the contacts to keep changing. But how do we make sure that happens automatically? We can do that by attaching split rings. Split rings, as the name suggests, is a ring that is split in between, giving two half rings with some gap in between. Now let's see how this arrangement automatically changes contact for every half a rotation. So right now, this brush is in contact with the pink side. But as the coil rotates and comes to this position, the current reverses, and now notice the brush is in contact with the blue side, making sure the current still flows in the same direction through the bulb. Again, as the coil comes to now this position, finishing another half a rotation, again notice it just changed contact. It is now in contact with the pink ring, connected to the pink side. And this way, we have now built our DC generator, where the current only flows in one direction through any external circuit. And this arrangement, which helps us automatically change contacts, we call them as commutators. So split rings act like commutators. So to summarize what we learned, if you take a coil and spin in a magnetic field, then due to electromagnetic induction, a current gets generated in that coil. Now the direction of the current depends on whether the wire is going up or whether it's going down. And as a result, for every half a rotation, we see that the direction of the current keeps changing. And so this generator is called an AC generator because it generates an alternating current, a current whose direction keeps continuously changing. On the other hand, if we use split rings, then it acts like a commutator. It keeps changing the contacts for every half a rotation and makes sure that the current does not change the direction in the external circuit. We call this a DC generator. And so this is how we can generate electricity just by rotating a coil in between a couple of magnets.